Hello students, today we're going to be talking about perpendicular bisectors. This is the third unit, lesson number 6. We're coming up to the end of that third unit, so be prepared for a test coming up shortly. Let's take a look at the learning target. In the learning target it says we're going to be developing a method for graphing perpendicular bisectors and composing a perpendicular bisector equation for a segment. So let's just try to make sure that we all know what perpendicular and bisector mean. Specifically that perpendicular means that the lines intersect at right angles, and bisector means it cuts a figure in half. So if I give you a line segment, you should be able to find a perpendicular bisector, something that is perpendicular, forms right angles with the line segment, and cuts that line segment in half. Once you find that perpendicular bisector or graph the perpendicular bisector, you must be able to compose its equation. It's actually a little bit easier than you might think it is, but it just requires a couple of steps that you need to keep in mind. So for the do now, it asks you to find the midpoint of each segment. They give you one graph and one set of ordered pairs. Go ahead and try to figure this out, pause the video, and then come back to see if you got it right. All right, in this first problem, we set up the midpoint formula. We filled in the information from the given points. All we had to do was write out that this point was -5, -5, and this point was -1, -1, and then substitute those into the formula. We eventually got -3, -3, and when I graph that point, it definitely looks like it's halfway between those two other points, right? We go up and over twice to get to this one, and then go up and over twice to get to the end point. So midpoint checks out. That is -3, -3. The next one, it's given to us already, the endpoints. So all we have to do is apply that midpoint formula one more time. It's a very similar procedure. x1, y1, x2, y2. We've labeled our points, and then we substitute the points into the formula. -4 and 5 go in here. 4 and -1 go in here. And then simplify. 4 plus -1 is 3. 3 halves is equal to 1.5. -4 plus 5 is 1. 1 half is equal to 0.5. So we've got our two midpoints. Not too bad. And yes, it's okay that midpoints are decimals. Decimals are people too. Let's take a look at the review. You already know that the slope formula is rise over run, which is y2 minus y1 over x2 minus x1. This is already known to you. You already also know from the previous lesson that if lines are parallel, then their slopes are the same. If lines are perpendicular, then their slopes are negative reciprocals. And you know that negative reciprocal means to flip the sign and flip the fraction. In other words, we take the original sign, which is negative, and turn it into a positive. We take the fraction, which is, in this case, 6 over 7, and change it to 7 over 6. Negative reciprocals means we flip it upside down and change the sign. You also know the midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. We literally just used it, and that's the midway point between two endpoints. Let's take a look at the guided example. It asks us first to find the slope of the line segment. We can find that slope by using the slope formula, which is y2 minus y1 over x2 minus x1. All right, just like in the previous problem, we labeled the 2 points, then we identified which one is x1, y1, and which one is x2, y2. Then we identified the slope formula, which is y2 minus y1 over x2 minus x1. Our slope is equal to 3 over 2. We could have alternatively figured this out by doing rise over run. If I go upwards by 3 and over by 2, I get to another point on the line segment, and then similarly up 3 over 2, I got another point on that line segment. So I could have found slope either way. This is the way that I prefer, and your grader will prefer, because this is the algebraic way you can show your work. Next, we're supposed to identify the slope that is perpendicular to the line segment. Remember, perpendicular means negative reciprocal slopes. So in order to identify a negative reciprocal slope, we're going to take our slope that we found from the previous problem and flip it upside down and change its sign. Positive goes to negative. 3 over 2 becomes 2 over 3. So the slope of the perpendicular line is -2 divided by 3. Not too bad, because all we have to do is take that slope and, as I said, change its sign and flip it upside down. Next, for section C, we're asked to find the midpoint of the line segment. We sort of found the midpoint here by doing that rise over run method. This is the graphical method of finding midpoint, so we know that the midpoint should be -1, 1. But there's another way to do it, and that's by using that midpoint formula, which I will show you now. So here are our 2 points. Here's the midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2. We substitute the values -3 and 1 in for the x's, and -2 and 4 for the y's, and we should get 2 over 2, which is -2 over 2, which is -1, and 2 over 2, which is +1. As we predicted, -1, 1 is the midpoint. Last but not least, we need to write the equation of a line. Well, let's figure out exactly what it's asking for. We need the equation of a line, which means we need y equals mx plus b. And that line has to be perpendicular, which means negative reciprocal slopes, to the line segment that crosses at the midpoint. So remember, midpoint is the point that we found here. So we need y equals mx plus b. Of course, you know in y equals mx plus b, we need two pieces of information. We need the slope, and we need some kind of y-intercept. We don't have the y-intercept, but we do have the slope, so let's start with that. And if you'll recall from previous problems, in order to find the y-intercept, we need to substitute in one point that we know is going to be on the line, one x value and one y value, so that we can find the b, find the y-intercept. Well, it turns out that we do have one point that we know is going to be on the line. That one point that we know is going to be on the line is the midpoint. It crosses at the midpoint. So we're going to take this midpoint and substitute it in for x and for y. Here's how it looks. So we substituted x is equal to -1 and y is equal to 1. Once we solve this out for b, we multiply these two together and get positive 2/3, and we subtract 2/3 from both sides to get 1/3 is equal to b. Yes, it's okay that there's a fraction for the y-intercept. Just like decimals, fractions are people too. So now let's try to write out the actual equation. It has to start out with y equals mx plus b. And it also has to include the slope, which we know already, and the y-intercept, which we just found. And this is the equation that we just baked up by identifying the negative reciprocal slope and the y-intercept if that negative reciprocal sloped line passes through the midpoint. This equation is a very special equation for the line segment. Remember the line segment here? Let's take a look at what this line looks like in comparison to the line segment. So let's grab this equation and let's bring it up there. Now let's try to graph that equation. Go ahead and try to graph it yourselves and then come back to the video and see if you got it right. And here's that graph. We took this equation, which is a perpendicular line that intersects this line segment at its midpoint, and we graphed it so that you can see that it intersects this line segment at right angles and it cuts this line segment in half at its midpoint. There's a very specific name for this line, which cuts the line segment in half and is perpendicular to that line segment. You probably could have guessed what the name is. That term is perpendicular bisector. This line is a perpendicular bisector for this line segment. Now that the mystery is gone and you know what a perpendicular bisector is and how to find it, we can start taking a look at some of the problems. Keep in mind the steps that we had to go through in order to find the perpendicular bisector. First, we had to find the slope of the line segment. Then we had to identify the slope of a line that was a negative reciprocal or perpendicular to that line segment. Then we found the midpoint. Then we wrote out the equation by identifying the y-intercept. So those 4 steps are the steps you need to go through in order to write the equation of a perpendicular bisector. As was stated previously, let's take a look at perpendicular and bisector as vocabulary words. As you know, perpendicular lines are two lines that form a 90-degree angle and have negative reciprocals. A bisector divides a figure into two congruent parts. The bisector for a segment is known as a midpoint. That midpoint is a segment bisector. So a perpendicular bisector does both things. A perpendicular bisector forms 90-degree angles with a pre-existing line segment, and it divides a figure into two congruent parts. It could be a line, it could be a line segment, or it could be a ray, but what it does is it cuts the thing in half and forms right angles. So it intersects the segment at its midpoint and forms right angles. With that information in hand, let's take a look at the model problem. We're supposed to write an equation for the perpendicular bisector. Let's underline that real quick because that sounds important. Of PQ. P has coordinates -6, -2, and Q has coordinates 4, 6. Breaking down this problem into the steps that we looked at for the guided example, let's try to figure out what to do first, second, third, and fourth. Pause the video and try this out, and then come back to see if you got it right. All right, the first step is to find the slope, and we found the slope very easily. That slope is 4/5. Remember that next step is, since it's a perpendicular bisector, we need NRS, which stands for negative reciprocal slopes. That's a pretty easy step. We took 4/5, which was the slope of the original line segment, and we turned it into its negative reciprocal by flipping it upside down and changing the sign from positive to negative. Our third step is to find the midpoint. So this is kind of a tour through all of the different coordinate formulas that you used in a couple of units ago. You can see step 3 here where the midpoint is x1 plus x2 over 2, y1 plus y2 over 2, we substituted and simplified, and we got -1, 2. That's our midpoint. Now remember, we need two things to write the equation of a line. The equation of a line is made up of a slope and also a y-intercept. We have our slope already, but now we need our y-intercept. We know that the line is going to use this slope and pass through this point, which is a perfect x, y, to use in our equation. So we're writing out y equals mx plus b. We are substituting -1, 2 into the equation for x and y, and we're using -5/4 because that's our negative reciprocal slope. Solving this equation gives us 3/4 is equal to b. In other words, the y-intercept is 3/4. So now we have all the information we need in order to write out the equation of this line. So the equation of the perpendicular bisector is y equals -5/4 x plus 3/4. We can verify this by graphing the line segment onto this graph and then graphing the equation of the perpendicular bisector. And there you go. I've drawn that perpendicular bisector, that line that splits line segment PQ into two equal pieces, and it intersects at a right angle. And here are the markings, the appropriate markings to prove it. All right, I would go over the check for understanding, but alas, that is for class. So we've reached the end of the video about perpendicular bisectors. Again, this was Unit 3, Lesson 6 on perpendicular bisectors, which are lines or line segments or rays that split a line segment in half and intersect it at a right angle. Good luck studying.